All right, so we've looked at ethane, ethene, and now we're on to ethyne, which this is the Lewis structure of ethyne. Just looking at this Lewis structure, we can see that the carbon atoms have a triple bond as one molecular group, and a hydrogen is a second molecular group. So they have two molecular groups. The way to get them as far apart as possible is a linear geometry. So if we wanted to draw the real picture of what ethyne would look like, we would put the C triple bond C, and then the H's directly out. So there's a 180 degree, not Celsius, 180 degree angle between the carbon atom and the hydrogen atoms. What about the orbitals involved in this bond, in the CC triple bond? So with two different groups, we need two hybrid orbitals, so we're just going to hybridize an s orbital and one p orbital. So that would mean that we are left with two different sp orbitals and then two p orbitals. So these are the orbitals in an alkyne, or in an sp hybridized carbon atom. So what orbitals are involved in the CC triple bond? So again, we have to think about sigma bonds and pi bonds. The sigma bonds are going to result from a CSP to a CSP orbital, and then we have two different pi bonds, and both of those are from a CP to a CP. So what does that look like? So again, the p orbitals are on different axes, right? So there's one on a y-axis, there's one on an x-axis, and both of those are going to overlap to form the two different pi bonds. So on page 15 of your notes, we have that kind of outlined. We have two different axes of p orbitals, and we can see them here overlapped to make two different pi bonds. So just like when we had a single pi bond, we're not going to have any rotation around that molecule, and it's going to be linear. The molecular model kit for this, just as a straight structure, so here's the hydrogen, here's a carbon, here's another hydrogen, has that 180 degree linear shape. It shows, you can kind of see a little plus sign pretty much, and that's to show there's one pi bond on this axis and one pi bond on that axis. So that's what a triple bond looks like. That's what ethyne looks like, and that's kind of the last of our three-part discussion of two carbon-containing molecules that are either just single bonded, double bonded, or triple bonded. I finish up the notes just with showing the chart that is in your guys' book. So it shows the number of groups. So if you have two groups, you have to have two hybrid orbitals. So the type of hybrid orbitals for 2 and 2 would be two sp hybrid orbitals. So that's the case that we have right here. What else does it show? Three groups. Three hybrid orbitals are necessary, so you're going to have three sp2 hybrid orbitals. Four orbitals are necessary, so you have four sp3 hybrid orbitals. So that's ethyne, and in the next video we're just going to look at two different new molecules, and we'll talk about the different positions in there. So